In this video, we'll review the law of cosines. The law of cosines is a very powerful tool to help me find missing angles or sides in any triangle. It does not have to be a right triangle. This will work for any triangle. So the law of cosines goes like this. It almost looks like Pythagorean theorem, c squared equals a squared plus b squared, but it's got a correction, the whole minus 2ab cosine of c. The minus 2ab cosine of c is how I adapt it to work for non-right triangles. Now I can write it a little different. This is what I write when I'm using angle C. If I'm using angle C, then I've got to start with c squared by itself. If in the next example I'm using angle A, then I'm going to start with a squared by itself, in which case it'll look like a squared equals b squared plus c squared minus 2bc cosine of A. Or, in the last example I'm using angle B, then I'm going to start with b squared by itself, in which case b squared equals a squared plus c squared minus 2ac cosine of B. Now this may look like three different equations, but it's really not. There is no hypotenuse to these, which is what C usually stands for in Pythagorean theorem, because these aren't right triangles. If there's no right triangles, there can't be hypotenuse. We just have three sides. So you just got to make sure that whatever angle you're using, the side that's opposite from that is the squared piece that's by itself. So if you're using angle C, then c squared has to be by itself. Or in the next example, if you're using angle A, then a squared has to be by itself. Or in the last example, if we're using angle B, then b squared is by itself. So you really don't have to memorize three formulas, just memorize the one and understand that it can adapt for the different letters. So let's take a look at an example here. In this example, it's not a right triangle, which means I cannot use trig and I cannot use Pythagorean theorem. Instead, I would have to use either law of sines or law of cosines. Now I prefer law of sines, but I can't use it here. I have the 105-degree angle, which has b opposite of it, which is what I'm solving for. But on the 12-meter side or the 15-meter side, I don't know the angles that are opposite from those. So I don't have enough information for law of sines. Instead, I have to use law of cosines here. Using the law of cosines, if I know angle B, then I've got to start it with the b squared piece by itself, in which case b squared equals a squared plus c squared minus 2ac cosine of angle B. Substituting in what I know, I get that b squared equals the 15 squared plus the 12 squared minus 2 times 15 times 12, cosine of 105 degrees. Now to work this problem out, I'm going to go and square the 15 and the 12, and I'm also going to multiply the 2 times 15 times 12. 15 squared works out to be the 225, plus 12 squared, which is 144, add together to be 369. 2 times 15 is 30, and 30 times 12 is 360. So I get b squared equals 369 minus 360 cosine of 105 degrees. At this point, I'm going to have to use my calculator and approximate. I'm going to figure out what the approximation for 360 cosine of 105 degrees is. And it turns out to be about 93.17. So now I know that b squared is about, again using the approximation symbol, 369 plus 93.17. Adding those two together, I get that b squared is about 462.17. I'll now use my calculator and approximate. B would be the square root of that, meaning we're going to work out to be about 21.50 meters. So let's try another example. In this one, I want you to try working it out on your own, pause the video, and when you're ready, resume the video to check your answers. Please work it out ahead of time to make sure that you know how to do it. Don't just watch the video and assume that you can do it. Hopefully you've had a chance to work this one out, so let's see how you did. In this, we know angle A. We're trying to find side BC, which is opposite of angle A, so we can also call that little a. So we know that the little a piece, the a squared, is going to be by itself. Again, the a squared is by itself because we're using angle A. So when you set up law of cosines, it's going to be a squared equals the b squared plus c squared minus the 2bc cosine of angle A. Substituting in what we know, the little a side would really be side BC, so it's BC side squared equals the 15 squared plus the 14 squared minus the 2 times 15 times 14 cosine of 71 degrees. In the next step, I'm going to go ahead and square all these pieces out. 15 squared is the 225 plus the 14 squared, which is 196, add together, minus the 2 times 15 times 14 cosine of 71 degrees. In which case I get 421 minus the 420 cosine of 71 degrees. Now I'm going to go ahead and approximate. Now I can do this in two steps. I can say it's 421 minus and then figure out what 420 cosine of 71 degrees is, or I can type the whole thing in and just go 421 minus 420 cosine of 71 and figure out what that whole thing approximated is. And it turns out that's approximately 284.26. Now to finish solving for BC, I need to square root both sides. meaning BC is about the square root of the 284.26, or BC is about 16.86 inches. The law of cosines can be used for more than just missing sides. We can also use it for missing angles. So here's our last example. I want to solve for x, which is an angle. Now I can't use trig because it's not a right triangle, and I can't use law of sines because I don't know one of the other angles already inside the figure. So I have to use law of cosines. Now to use law of cosines here, you have to know the three sides and try to find one missing angle. I can actually find any of the angles on this problem, not just angle x. Using law of cosines, if I'm solving for angle x, I've got to make sure that the piece that's opposite from that, in which case 35, is the piece that's by itself. So to use law of cosines here, the 35 piece is going to be by itself. Now I can set up any of the equations. I'm going to use this one. I just got to make sure that when I plug it in, 35 is by itself, so 35 squared equals, and then the 20 squared plus the 30 squared minus 2 times 20 times 30, cosine of x. Now the reason I'm setting it up like this is because I'm solving for x, which is the angle, that is opposite the side, which is 35 meters. Those pieces are opposite from each other, so they're going to go opposite from each other in the equation. All right, working this out. 35 squared turns out to be about 1225. Sorry, is exactly 1225. The 20 squared plus the 30 squared is 1,300. 2 times 20 is 40, and 40 times 30 is 1,200. Now to finish solving this, you cannot subtract the 1,300 minus the 1,200 cosine of x. That does not work. The 1,300 and the 1,200 cosine of x are not like terms. Don't combine those. Instead, I'm going to solve for this by subtracting 1,300 from each side. If I do that, I get that negative 75 equals the negative 1,200 cosine of x. Now that's negative 1,200 times the cosine of x. To finish on doing this, I'm going to now divide both sides by 1,200, negative, and I get that the 0.0625 equals the cosine of x. Now I'm going to use the decimal here because it's an exact one, but I could have also used a fraction. I could have said that negative 75 divided by negative 1,200 equals the cosine of x. And you can do that, or you can even reduce the fraction if you want. Any of them is going to work. It's all going to work out to be the same thing. Again, I only did the decimal here. I don't usually do the decimal, but I did it here because I knew it was an exact answer. Now to finish solving this problem, I'm going to have to use inverse cosine. So to do that, I'm going to say that the measure of angle x is the inverse cosine of the 0.0625. And it's going to look like this. Or you can say x equals the arc cosine. Typing this in the calculator, I go second cosine, type that in, and I'm going to find out that the measure of that angle is about 86.42 degrees. So in this example, we see that the law of cosines can also find missing angles. Now I wouldn't want to do this if it's a right triangle, because if it's a right triangle, trig would be much quicker than this. So really law of cosines is kind of like the last resort. If it's not a right triangle, I can't use trig. It's not something where I can use law of sines. So in this case, I have to use law of cosines. But it is a very powerful tool because it always works. All right, thank you for watching, and I hope this helps you to understand how to do law of cosines.